Unfortunately, even with smaller models, there is a good chance that wrong behavior has been implemented by mistake. So how can we test our VHDL model? Hello and welcome to this video. In this final episode about VHDL fundamentals, we will have a look at so-called test benches. Test benches are only meant for simulation, and this allows them to make use of VHDL statements that are not synthesizable. On the left-hand side, you can see the structure of such a module. A test bench provides stimuli to test the MUT, the model under test, and checks its response by comparing the expected answers with the ones received from the MUT. The test bench itself is implemented in VHDL. In contrast to the model you design, it consists of an entity without any I/O ports. Let's have a look at the two parts of the test bench surrounding the MUT. First, the stimulus for the MUT has to be generated. There are two different ways to implement this. Here you can see an example of stimuli description using absolute time. In this case, we can use the keyword after to assign values to a signal after a certain time. Usually, this is implemented using concurrent signal assignment, hence outside of a process. An example for using absolute timing in test benches is the generation of the reset signal. Here's an example of how to implement this. The reset signal is initialized with the value 1, since this happens after 0 nanoseconds. After 100 nanoseconds, the reset signal is set to 0 to end the reset phase. It is always good to implement a reset signal in your model to define a safe initial state where all relevant control signals are well defined. However, it is also possible to use sequential signal assignments for generating stimuli. Let's have a look at such an example. Inside a process, we can use the wait statement to describe the stimuli based on relative time. In this case, after 10 nanoseconds, the signal net12 is set to 1, and after additional 20 seconds, that is after 30 nanoseconds in absolute time, it is set to 0 again. The process then restarts after the end has been reached. For sequences that are only meant to be run once, the wait statement without specified time makes the process wait indefinitely, preventing it from starting again. But sometimes we can exploit this restart mechanism of a process to generate signals such as the clock signal. Here you can see a simple example of how to generate a clock signal of 100 MHz using a process. Every 5 nanoseconds, the signal value of clock is toggled from 0 to 1 or vice versa. Okay, so now let's move on to the second part of the test bench, the response control. It is responsible for checking the output of the MUT with a given value. Here you can see an example for such a response control implemented in VHDL. To check the output signal values of our MUT, we can use the ASSERT statement in simulation. The advantage of using this approach is that it generates an error message if the condition in the parentheses is not fulfilled. So in the first case, if the signal read is not equal to 0 after 5 nanoseconds, the ASSERT statement generates an error message that can be read in the simulation environment. Similarly, after 15 nanoseconds, if the value of the signal read does not equal 1, an error message will be generated. So now we know how to implement a test bench in VHDL for checking the behavior of a model in a simulation. With this, you will be able to identify and remove different kinds of misbehavior in your model already before running it on an FPGA.